I was logging into my bank account the other day, and I noticed that when I typed in my password, it appeared as a bunch of asterisks. Why did that happen, Abigail?
Well, Grandpa John, that's because your password was encrypted.
Encrypted? What does that mean?
Well, you don't want anybody to know your password, right?
No.
Or else they could log into your bank account and pretend to be you.
That would be bad.
That's why your password is encrypted. That means that your password is converted into a cipher, so that other people don't know what your password is. Encryption is one part of cryptography, which is the art of writing and solving codes. Encryption is my favorite aspect of cryptography because it is applied in so many tasks you can do in daily life.
Well, in what kind of ways is encryption a part of my life?
Every time you need to access an account to pay your taxes or even just play an online game, you need to authenticate yourself with the correct username and password. However, you don't want everyone to know what your password is in the process, because then someone else could impersonate you. That's why encryption comes into the picture. Your password is encrypted in a form that is unintelligible to anybody who does not have the correct key to decrypt the ciphertext back into readable plain text.
Oh, well, I never thought about that.
My favorite method of cryptography is the zero-knowledge proof. In the zero-knowledge proof, you prove that you know something without actually revealing anything more than the fact that you know it.
Wait, what? How would that work?
I'll use an analogy to explain it. Suppose I put on glasses, and these glasses make it so that I'm unable to distinguish between two colors. Now you come to me and show two pieces of paper that are identical, except that they have different colors. You claim to me that they have different colors.
But since you have the color-blind glasses on, you won't know for sure if they are actually different colors. You would just have to take my word for it. I think the easiest way for you to verify my claim is to take off the color-blind glasses and just see the two papers.
Of course, but suppose that you want to convince me that the colors are different, without revealing the actual identity of the colors.
Wait, how is that possible?
Here is where the zero-knowledge protocol comes into play. Let us call one of the papers paper A, and the other one paper B. I ask you to step out of the room. I toss a coin. If I get heads, I hide paper A and show paper B. You come back into the room. I ask you which one is the paper that I did not hide, A or B. If the colors are actually different, you will be able to give the right answer 100% of the time. If you wanted to fool me that the papers are different colors, the probability of you getting it right by random guessing is only 50%. We can repeat this test as many times as we want, and if the colors are truly different, you would get it right every single time. The chances of you getting the test repeatedly correct by guessing is extremely unlikely, as the number of trials increases.
Yeah, that would work. And ultimately you are convinced that the colors are different, but did not learn anything besides the fact that I know the colors are different. I managed to show the only fact I wanted you to know, and did not expose the actual identity of the colors.
Correct. That is the beauty of cryptography. You can achieve the most non-intuitive tasks.
I see. This relates back to the password to my bank account. I managed to prove my identity to the bank without revealing the actual contents of my password.
Yep. See how cryptography is so integral to our daily lives. Without it, you would not be able to safely access your bank account online, because your password would be completely exposed to third parties, and they may use it for malicious purposes.
I know why it's so important now, but how exactly is it encrypted?
One classic method is the Caesar cipher. I'm so nerdy that I have a framed picture of a Caesar cipher in my office. The Caesar cipher is a type of substitution cipher. Each letter in the plain text is shifted a certain number of places down the alphabet. For example, if I shift the plain text by 2, A would be replaced by C, B would be replaced by D, and so on. The ciphertext would write the message using this new shifted alphabet. This encryption scheme is called the Caesar cipher because Julius Caesar apparently used it to encrypt communications with his generals.
But if I knew that the message was encrypted with the Caesar cipher, couldn't I use trial and error and shift the alphabet until it translates the cipher text into the plain text?
Yes, the brute force method can be used to crack a Caesar cipher. So a Caesar cipher is not a particularly strong encryption scheme. There are other schemes that are much harder to crack, but I think those might be a little too technical for you to understand, Grandpa John.
Yeah, my mind is blown enough already. If I learn another encryption scheme, my brain will explode.
Yes, that's enough for today. I better get back to work.
I'll think about this conversation every time I log into my bank account. Thanks, Abigail.
Anytime, Grandpa John.